everyone. So we are now on our synchronous session number 9. So for this afternoon, no, we will not be having. We will just be having a very short session because there has been a power interruption no, in our area since morning, and then wala pa siya sure kung kansa siya mabalik. No? So, basi dili na kaya nun sa battery sa laptop, no? So, basi namatay na siya in the middle of our session. So, I'd like to have this session as short as possible. No? So, I will not be discussing na the seepage, seepage nga discussion or the topic about seepage kay siguro na-gets naman tingin nato no dato sa pre-recorded discussion. Pero anyways, you can raise your concerns later no after I will discuss the solution for the quiz. So basically this afternoon I will just be presenting the solution for your quiz number 7. Seven ba? Yes. Seven for the topic C page, no? So allow me to share my window. Alright, so makita na ba siya?
Yes, ma'am.
Yes, ma'am.
Okay. So murag gamay raman ta no. I really have to start already because kasi mulobat gyud ang laptop no and then di na ako maka-discuss. Anyways, this session is recorded and then for those who are not able to attend siguro by the time we dismiss, I will just be sending the solution to our group chat no para dali siya makita. Okay, so our problem number 1 no, we are given with this figure. And then we are asked to solve for how high, na number 1, how high daw the water will rise if the piezometer are placed at points A, B, and B, C, and D. So, tagsa ni siya dito, no? Tagsa ni siya ka-item. So, basically, ang pangutan na dala kay, kung mag-insert daw kag piezometer, kaya di ba, ang piezometer will measure man the height of the water which represents the pressure no in that specific area of insertion there sa atong soil strata. So first we have to solve no ko di ba kada square kada approximate square na ay head loss no di ba our water will flow no from a higher pressure no ay kung mas taas ang level sa water mas taas magiging pressure no kay pressure is very much dependent on the H no kay di ba pressure due to water is equal to gamma H bar A di ba so or gamma H ang H na no the greater the depth the greater the pressure so that's why there is a seepage ang yahang mechanism ba? Or basta mechanism. The water will flow from a higher elevation to a lower elevation or to lower pressure and it will flow or it will travel through a permeable layer which is this one no our soil in here is permeable no permeable siya diri nga part and then gi-indicate po niya diri kay nga impervious na daw siya ani beyond this point so that's why our water no will seep through our soil similar to this direction no so gikan diri padulong dara no so as our water travels through our permeable soil gikan diri no from point AB kada mag-travel siya dara na siya head loss nga ma-experience so ang kanang head loss is very much dependent on the number of drops kani sa atong flow nets nga i-construct kay one way siguro yes one most common way for us to solve for the seepage rate no or how seepage rate sa man seepage rate in another term how fast is the water does the water flow no or mo siya speed of water pero actually di siya speed how fast or what is the characteristic of the movement of water beneath our soil, something yan. It defines the seepage rate of our soil. So that's why we have to construct our flow nets. So our flow nets are composed of the flow line, no? And then our equipotential line, yun na siya itsura. And then the intersection of these lines create an approximate squares, which we refer to as number of potential drop. So kanang kada potential drop, meaning na potential drop, no? So kag maagi diha ang tubig na siya'y drop sa iyang head, sa iyang pressure head. So if we are going to consider this point A, sa atong water daw upon reaching point A, if you are going to insert a piezometer there, pila kunoy pressure through that piezometer, ma-measure man nato ang pressure, no, through the height of the water in the piezometer. So kung sa point A, we have here the solution, no. First, we have identified the number of flow channels and then the number of drops. So atong yapon nganong 4 siya and then nganong 6. So ang number of flows is we have 1, 2, 3, and 4, no. NF refers to the number of flow channels, no, kani murag area bounded by the flow lines. And then ang the number of drops is actually the number of approximate squares created by the intersection of our equipotential line and the flow line. So we are going to count now. For example, we are going to consider the flow channel number 3. So we're going to count 1, 2, 3, 4, 5, and 6. So as described, no, in the pre-recorded discussion, similar na siya or equal ang number of drops or number of approximate square kada flow channel. So kung kading flow channel 3 naa siya 6 ka number of drops, that is the same with flow channel number 4 and flow channel number 2 and as well as number 1. So ana siya, no. It is very much important that we identify first our NF and our ND. Kaya mga formula ra ba sa seepage, magamit din sila tanan sa NF o sa atong ND. So karon na-identify naman nato, no, ang ato ang na number of flow channels and number of potential drops. So we are going to compute kung pila ang loss of head or head loss or drop, no, sa kada pila how much, no, ang i-drop sa kada square nga maagian sa atong water. So to do that, we have to get the difference between the water level, no, or that is actually the pressure head between the two elevations of water. That is 6 minus 2.5, kay 6 man to H1 and then ang H2 is 2.5, that is equal to 3.5. So since equal man daw ang loss of head, no, kada approximate squares, and we have 6 approximate squares, so kaning 3.5 nga difference sa ato ang pressure, i-divide sa kada isa niya ato. So that would be 3.5 divided by 6. So we would arrive with the value, no, loss of head equal to 0.583 meters. So kada square daw ani na ay head loss nga 0.583 meters. Alright. So karon mag-consider na ta ato mag-ihap-ihap, no. So at elevations A, B, C, and D. So basically, ang pressure head diri nga point is 6 man, di ba? 6 because H1 is 6. So if our water will flow this direction, no, at point A, mabot siya point A kay bali. So pila na lang ang iyahang pressure din ha. Basically kung mag-insert yung piezometer, mabalaan man nimo, no, that will be equal to the rise of the water in the piezometer. So kung 6, mamainusan siya og isa, di ba? Maagi siya isa ka approximate square. Therefore, the pressure head at point A would be equal to 6, no? Initially 6 minus isa ka potential drop, so that would become 6 minus isa ka 0.580, that would be equal to 5.417 meters. And then at point B, so there na punta, no? So originally 6 man siya, no? So mo-travel siya, butang nato ang water. From here, mo-travel siya 1 potential drop, or 1 isa ka square kibali ang nagian, and then 2. So na siya dere point B, meaning nakaagi siya duha ka square, and then kada square na is 0.580. So that's why 6 that would make it 6 minus duha ka 0.583. Sama ni siya. 6 minus duha ka 0.580, that would be 4.834 daw. So meaning kung mag-insert na kay piezometer dere, the rise of the water inside the piezometer would be equal to 4.834. So the same ra pud no sa C ug sa D. Ang C ug D pareha sila 5. 5 daw ka 0.583, meaning 5 ka square daw yung naagian. So let us illustrate that here. So from 6, no, mo travel atong water, we have 1, 2, 3, 4, 5, 6. Namang C dire. Again. So from 6, magi siya 1, 2, 3, 4, 5, 6. So 6 ka squares. So makaagi po siya 6 ka drop, which is equal to 0.583 each. So sa ato po tang point D, no? So from 6, mo travel siya 1, 2, 3, 4, 5, 6. Ano? 1, 2, 3, 4, 5. Anong 5? 5 siya? Oh no. 1, 2, 3, 4, 5. Okay. Maybe, 5 ra day, no? So basically, ang ihap ani is, naadiri ang point C. 1, 2, 3, 4, 5. Exacto di ay. 5 ra jud day siya. 1, 2, 3, 4, 5. Ay, sakto di ay. Sorry. 5 ra day siya, no? So from 6, 1, 2, 3, 4, 5. So na din siya dara. And then sa 6, sa point D is 6 na 1, 2, 3, 4, 5. So na din ang point D. So muna siya tag 5 sila daw ka potential drop equal to 0.583 each. So basically that would make them have an equal elevation, no? Equal to 3.085. So for the second question, so I'm very sorry if I would really have to somehow murag pagdali, no, kay murag katong na lang ang battery sa akong laptop. Okay. So for the second question, we are asked to solve the rate of the seepage through the flow channel number 2, no? So number 2 ra daw ang kuhaan og seepage rate. So here's the solution. K is equal to the seepage rate is equal to K times H over ND. So ang H is already given, and then our K is converted or was converted to meters per second, no, to match the units or to have a consistent unit. So ang H over ND, we have previously solved this, which is equal to 0.583. Yes, 0.583. So you just have to multiply them both, and then you will arrive with the answer. The seepage rate equal to 4.664 times 10 to the negative 5 cubic meter per second per meter, no? Na per meter kay ang per unit width daw ang giingon. So mag-consider tag 1 meter straight. That's why na siya per meter or per liter meter na rin nga unit. Per usually ana inana mo siya no, per unit width gid siya. So for kibali mo daning seepage rate sa flow channel number 2 ra. So kay since equal man og seepage rate ang kada flow channel, no, ka-equal mo siya number of drops. So if you are going to be asked for the total rate of seepage through the permeable layer per unit width, you just have to multiply the seepage flow or the seepage rate of one flow channel to the number of flow channels, which is equal to 4. No? So 4.664 ang seepage rate sa isa ka flow channel, so, and then na may upat, no? So you just have to multiply that by 4, arriving with the total seepage rate of our permeable layer equal to 1.8656 times 10 to the negative 4 cubic meter per second per meter. So, muna siya ang question number 1. So, our question number 2 is, we are asked to compute for the seepage or uplift force on the base of a masonry dam shown. So, with its corresponding flow nets. So, basically, we are, although a lot of you may have been confused kung unsa nga point ang i-consider diri kani sa iya nga problem, pero when we are actually trivial mo lang tani siya, no, nga question para sa inyo kay para you will siguro research mo as mean uplift force o nga nang murag karon pa kadong anis. I also given the hint naman po. So siguro you have already an idea, no, what is or what does uplift force is referring to. So basically, uplift force, no, at the base of the dam is caused by the water, no, beneath or right beneath the dam. So basically, we have to compute the pressure in here. Kaning area dire. Kana ra siyang area dana. So we have to get the pressure inside this area or within this area. Kay mura man pud ni ang pressure nga maka-affect sa atong dam, no? Na siya uplifting force, na siya uplifting effect sa atong dam. So given naman ang atong flow nets, so we just have to identify our number of drops and then the number of flow channels. Ang coefficient of permeability is already given, no? So, solution, no? H is 15. Nganong 15 man? Because that is 20 minus 5. So, if you're going to divide that with the number of drops, then you will arrive with ay lahi diyang formula ni gamit. Yes, divide niya. So that is going to be 15 divided by 10 down ka number of that. So we just have to count, no? Our H is 15. That is 15. That is 20 minus 5. And then the number of flow channels we just have to count. That is 1, 2, 3, and 4. So our NF is equal to 4. And our number of drops we just have to count it as considered the inner flow channel. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, consider po tag-outer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, our ND is equal to 10. So, we have the formula. Actually, ang kaning Q di rin, no, is not actually included in the question of this problem. Tama ba? Actually, wala siya gi-appeal, no? Murag additional lang ni siya. Pero basically, atong i-kuhaan diri is ang pressure head at A and then pressure head at B para makuha din nato ang iyahang total nga uplifting force due to that pressure. So we know man nga when water flows from a higher elevation to a lower elevation, na-ay drop, no? Na-ay drop in the pressure head. So basically, kung mas daghan iyahang potential drop nga maagian, mag-anang og kagamay ang iyahang pressure. So basically sa A, kung i-project mo na siya diri nga part, no, gamay pa yung maagian nga potential drop, meaning comparing to B nga mas daghan ang maagian nga potential drop, mas dako ang pressure diri sa A kaysa sa B. So that's why dili siya equal, no? Dili ka pwede makaingon nga mag-consider lang kada na o kanang straight no, rectangular strip kay varying, no, varying ang atong pressure head within the permeable layer. So we have to get, no, number one, magiging ang atong i-solve when we deal with seepage na problem is the loss of head or the head loss kada number of drop, no, so that is equal to the total head, no, the pressure head divided by the number of drops. So we have 15 minus 10, so kada square daw or kada approximate square natay 1.5 meter na pressure drop or head drop. So kung consider tag point A, let us count, no. Okay. Nara si point A diri ah. So mag-count ta, no, our water that will flow towards this direction. So tan-aw nato kung pilay ang magian nga number of potential drops. So you're going to count 1, 2, sa akong i-zoom para makita siya, no. 1, 2, 3, 4, 5, 6, 7. Apil ning dili 7. 1, 2, 3, 4, 5, 7 ba? Or 7 lagi, 7. So 5, 6, 7. Ang atong A is on the base of the dam. So basically, apil pagyapon siya diri, no, mga part. So we have 7 number of drops daw. So basically, from the height of 20 meters minus daw 7 ka 1.5 kay 1.5 man daw ang drop kada square. So mo ni siya, no. 20 minus 7 ka 1.5 times gitimes lang dayon niya og 9.81 diri to get the pressure due to water, no, kay this is the gamma and this is the gamma daw, this is the H bar or the H, and this is the gamma, no, because we know that the pressure due to water, no, is equal to gamma H. So since we are dealing with water, with known unit weight na siya, no? So we just have to multiply the pressure head with the unit weight of water, which is equal to 9.81. Then we would arrive with the pressure due to water at point A. So similar with point B, no? This is still the H, no, for our B. And then this is the gamma. And the pressure due to water at point B is equal to 49.05 kPa. So meaning, di ba, sa atong RC or sa atong theory sa una, we do not have a uniformly distributed load, no? Kay at point A daw, for example, dako 90 daw siya, no? Kanina lang illustration, 90 kPa daw siya. And then sa pag-abot sa B, 49 lang daw. So 'di ba actually ang kaning the force, or when you convert a uniformly distributed load or the varying distributed load, 'di ba ang area man ana, no, is just equal to the area of that load, yung iyang force. If you're going to get the force caused by that pressure or that stress, you just have to convert or compute its area, no. So basically, the force due to this pressure, kani nga pressure, itsura sa pressure, is just the area, no, of this um, distributed load. So that is 93.195 kPa plus 49.05 divided by 2 times 75 is equal to 5,334.2 kilonewton. So man na yung force due to, or uplift force due to the pressure caused by water underneath our dam. Okay. So do you have any question? Kay Marag ba tigid ko, no? So do you have any questions regarding our quiz number 7, C page?
Wala na, ma'am.
Wala na. Okay, so thank you so much and I really apologize kung we really have to end earlier. I hope okay sa inyo ha. Anyways, if you have questions, you may still raise it sa atong group chat so that I can address it. And for those your other classmates that were not able to join this session, so kindly advise them that I will be sending the solution to our group chat. So before we end, may I request everyone to please turn on your camera for a while so we can take our class picture for this session. Okay. So mag-smile na ta in 3, 2, 1. Smile. Alright, so mana. Okay, thank you so much no for your time and have a great rest of the afternoon and keep safe.
Thank you, ma'am.
Thank you,
Thank you,
ma'am.
ma'am.
Welcome.
Thank you, ma'am.